Problem? So, so far we've been doing statistics, and in semester 1, if you remember, at the end of semester 1 we did basic probability. Remember that? So we're actually going to go back to probability now. And we're going to look at something called probability distributions. What the heck? Okay, so if you can write that down. Yeah, probability distributions. You got this? Okay. So last time when we were looking at probability, it was really not many situations. We had situations where we could, for example, have A, or we could have B, and then what's this one here? This is A and B, yeah. Or other situations where, it was like you could have tea, or you could have coffee, and then maybe you could have cereal, or juice, or whatever, toast, no toast, toast and no toast, something like that. So we're going to continue with that, and we're going to look at probability distributions, or in other words, they're like tables. I know we had a look at tables as well. For example, we had men and women, smoke and don't smoke. Yeah. So we're looking at a different type of table now. So, do you remember doing this in statistics? So, for example, we had height and frequency, and these would be, 120 to 129, 130 to 139, etc. 5, 6, whatever. Do you remember what these were called? That's right, frequency tables, yeah. So what we're going to look at, the probability distribution, is a lot like a frequency table. It's like a probability table. So this is our first example here. And we'll pick something like grades. Let's try that again. Yeah. So we have grades. You can get A star, A, B, C, D, E, or U. So this first row, these are the outcomes. And in this case I call the outcomes G, which is just short for your grade. And then in the second row you write the probability of that grade. So these are the probabilities. So let's put in some numbers. So A star, what do you think the probability of getting an A star is? 1%? I think it's better than 1%. Yes, we'll say 10%. So here will be 0.10. What about getting an A? What will we use for that? 30?
No.
Oh, no. 50? 20? Let's say 15. Yeah.
What's the last one?
For this class, maybe. Maybe. You're right. Well, I never said these were maths grades, did I? Maybe these are EAP grades. Okay, a B will make it 20. And a C will make it 20. And a D will make it 20. So I have to be careful because here the total must be 1. So what have I got so far? 85. Yeah, 85%. So we'll make this one 0.10 and then this last one 0.05. Okay. So if you can write this one down as our first example of a probability distribution. Yep. You got this table? Yeah. Okay. So they're not really difficult to use. Let's just practice something very simple. So our first question then is, what's the probability of getting an A star or getting an A? Well, for this, the way it works is you just add the two together. So this would be 0.1 plus 0.15. So that's 0.25 or 25% the probability. Okay. Write that down. They don't multiply, they add together for this one, yeah. Okay, I want everybody to try this one for me. What's the probability of passing?
Is E passing or not?
Let's say passing starts from here. Yeah. 85, yeah. So it'll be, I mean, there's actually a quicker way to do it. In fact, if you did it like this, probability of failing, that's 15. 0.1 plus 0.05 is 15%. Therefore, passing must be 1 minus this, 85%. Or if you add those numbers together, you also get 85. Okay. Let's try something like, let's make it a bit more difficult now. Probability of, what else would be interesting? Trying to think of something interesting. Okay, this is not interesting. C or better. Try that. 65, isn't it? Yeah. 0.2 plus 0.2 plus 0.15 plus 0.10. 65%. Got that? Okay. Now let's make it a little bit more difficult. Can I scroll down a little bit, yeah? So this time, let's imagine what happened was the test was so difficult that they decided to delete the E and the U grade. So we remove the E and the U grade. So they decided test was too difficult, we'll remove these grades. And we change everybody's results. So for example, if you got an E, then they give you a higher mark because those have been deleted. So my question now is, I want you to make the new table. And in the new table, what's the probability of getting an E? It's 0 now, because they removed it. And what's the probability of getting a U? 0. So I want you to think about how you can recalculate the probabilities for the new table. Because remember, what should the total be? 1. And if I delete these, the total is not 1 anymore, it's 85%. So I'll give you a minute to think about how to do this, and then I'll do it. So I want you to remove E and U and then recalculate. Let's see what you come up with. No calculator, Athena? No calculator?
No.
Where is it? At home?
Yeah.
Good place. Did you recalculate? Did you have any ideas? Any ideas? No? Not right. You know it's not right. What did you do? What was your idea? Not 1. Yep. Not right.
Divided by 0.65.
That's it, yeah. Okay, so we have one person who figured out how to do it, at least. The trick here is the probabilities get redistributed, but the total still needs to be 1, and the total is now 0.85. So all you have to do is divide everything by 0.85. The proportion stays the same. So for example, which you can see here the B grade, if we look here, zoom in, yeah, you can see that the B grade is the same as the C grade. In the new table, should this be the same? It should be the same. That, you know, if in 100 students, if 20 got a B and 20 got a C, then in the new table, it won't be 20, it'll be more than 20, but you still want the B and the C to be the same. Do you want the A star to be less than the B? You do. The only way to keep the relative proportions the same is if you divide everything by the same number, in this case 0.85. Whoa, wrong way. Okay, so if I divide by 0.85, what do I get here? 0.118. And then what's the next one? 176, and then this one? 235. So I know that this must be 0.235, and the D? Oh, the 20? Yeah. Now, because I rounded, it might not add to 1, but it should be pretty close. Actually, what was it? So 0.999, I can live with that. So all we did was we divided each by 0.85, and then this makes the total go back to being 1. And there's actually a verb that means to do this. I wonder if anybody knows. $1 million for anybody who knows this verb. For $1 million, it's worth guessing, no? Do you want a verb that means to make the total go back to 1? I want a verb for this. What? No, good try. Oneification? No, like, what do you think? Or reverberation, reverb, reunite. Okay, so the verb here is re-normalize. So I'll just safely keep my $1 million right here then. So this is the verb that means make the total 1 again. You should write this down. It's a word I might use again. Re-normalize. And you can kind of understand the meaning, you know, re-normal. So make normal again. Something similar in Portuguese? Doesn't sound like anything you've heard before. Re-normalize. You know what I mean? Like make normal again. Yeah. Yeah. You have a word, but it doesn't sound like this. What is it? Sounds pretty similar to me. Right, re-normalize. Okay. Now, I think I'll do an example from the page here. Maybe we'll do one together and then I'll let you try them. Which one will be interesting? Yeah, okay. Well, anyways, let me give them to you first. So just take one and pass it along, please. I think we'll have a look at number 2. Also, just before I leave, look up, just before I leave this one and go on to number 2, before they deleted the E and U grade, what was your probability of getting an A? 15%. After the grade has been deleted, your probability of getting an A has increased. Instead of 15%, it's nearly 18%. So you've gone from a 15% chance to an 18% chance of getting an A grade, as an example. Okay, do you each have one of these? Yeah? So let's have a look at number 2. I think we'll do that together. Now just read it first before I do it. So just take 1 minute to read it and understand what's happening. How did you not end up with one? Oh, you have it, yes. Huh? Oh yeah, go ahead, Joe. Okay, did you read it? Number 2? Yeah. So, we have 10 horses are galloping in a race. Only 3 of them are likely to win. Lucky Stars, Pot of Gold, and Irish Charm. I'm sure some of you have betted before on horses, right? Galloping is the verb you use for when horses run. So it means running, but you only use it for a horse. I don't know why. Anyways, did you get that verb? So this verb here means run, but it's only for a horse. Anyways, the first one, you notice that there's a number missing on the table. I think we all know how to get that, so let's get that together. The total probability should be 1. So if I add these together and make it equal to 1, what's the probability that, what is the x? 10%. Okay. Right. What is the probability that none of the likely 3 horses win? So who are the 3 horses likely to win? Lucky Stars, Pot of Gold, and Irish Charm. So what's the probability that none of these 3 win? 0.10. Yeah. Now remember please that udder at the end, that's not one horse. How many horses are represented by the udder? 7. Yeah. Okay, good. Right, C. What is the probability that Lucky Stars or Pot of Gold does win?
70%.
Yeah, 70%. Okay. What is the probability that Lucky Stars or Pot of Gold does not win? 30%. How many times more likely is, no, that should be Lucky Stars to win than Pot of Gold? So in other words, how much more likely is Lucky Stars?
5 to 2.
Say again?
5 to 2.
Yeah, 5 to 2. But give that to me as a decimal though.
5 over 7.
No, a decimal with a point.
2.5.
2.5, yeah. So you can say that Lucky Stars is 2.5 times more likely to win than Pot of Gold. Okay. Got that written down? Yeah, okay. The next one. During the race, Lucky Stars falls and leaves the race. Construct the new probability table. Okay, so can you write that down? Lucky Stars has left the race. What is the new table? So it's just like with the grade example I did. What's the verb? Renormalize, yeah. Okay, so let's see. F. Horse and probability. So we have Lucky Stars, Pot of Gold, Irish Charm, and then other. Right, so now this is 0 because he has fallen. What does this become? 0.4, yeah, and this one? 0.4, and then this one now, 0.2. Great. Okay, G. Now, how many horses are in this other box? There's actually 7 in total. At the start of the question I said there were 10 horses. Yeah. Right. What is the greatest probability one of these horses has of winning after Lucky Stars has fallen? So if it helps, imagine that I change the box like this. You have horse probability. Lucky Stars is now 0. Pot of Gold is 0.4. Irish Charm is 0.4. And how many other horses are there? 7. So we'll just call them A, B, C, D, E, F. G. Thank you. Now, the total here must be 0.2. And I don't know how much they each are. But I do know what's the greatest probability one of them could have. What is that? Any ideas?
0.285.
No. 0.2. Because there could be a situation where maybe A is 0.2 and the rest would have to be 0. Now, of course, it's not going to be that, but you know that the greatest any of these could be is 0.2, because if one of them is more than 0.2, it means the total is more than 0.2.
Why we
which you
don't
can't have.
divide them equally, like the percentage?
Because I wanted the greatest, like the extreme case. Yeah. But yeah. Okay. Now, what is the greatest probability before Lucky Stars, not stars, Lucky Stars has? So before the horse falls, what is the greatest probability? 0.1. Yeah. And Malik, this is now like what you were saying. Assume that the other horses are each equally likely to win. So it'd be like X, 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 X. We'd have 7X equals 0.1. This is before the horse falls. So if we divide it equally, so divide by 0.7. Yeah, X is 0.014. Okay. I don't think there's much else to say. So it's the start of a new chapter. It's not so difficult. There's plenty of time. So you'll definitely get number 1, 3 and 4 finished before we finish. So if you can do 1, 3 and 4 now, and that will be the homework as well, but you should get them finished now. We don't have class tomorrow, right? No. Okay. Alright, try those now. Can I close this? Yep. Marcelo, can you get the light, please?